Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about one of the most prominent tools used for containerization. In the previous videos we spoke about containerization in detail, what are containers, but today we are going to look at Docker, which helps us in creating those containers. So let's get started. First of all, let us talk about why was containerization needed, or why did we need something like Docker. So one of the things that everybody would have said when they were developers, or the testers would have heard it from developers, is one of the syndromes which is there, which is called "it works on my machine" syndrome. Which means whenever we talk to a developer, a tester, let's say, raises a bug and tells a developer, or when we deploy our code from one environment to another, the common thing that we would face or we would say is that everything was working on my machine. How come it is not working now? So basically it's called it's working on my machine syndrome, and it is very frustrating when it happens every time we are deploying to multiple environments, or while we are shifting the things from our local machine to a different environment. And then it takes a lot of hours for us, or a lot of effort, to find out what actually is the issue. Why is the problem happening in a different environment and not on mine? Because there are so many dependencies, so many configurations, so many things that our code needs and that we already have on our machine. But just while packaging and putting it in another environment, some things may get missed out. And that is a very frustrating to and fro exercise to figure out the problem. And like I said, there are multiple challenges. There are challenges in terms of installations, configurations, patching, security upgrades. Because when we are operating or working on our local machine versus when we deploy the code somewhere else, there may be some differences between those two machines in terms of either the application code installation or patching or security upgrades or any kind of configurations or dependency that the code has, and we miss out on that. So troubleshooting all of this is a big nightmare. How can we remediate this problem? Because if we truly want to go towards CI/CD or pure DevOps, we want to minimize our efforts on installation, deployment and maintenance, so that we can spend all of those saved time or cycles into development. To do that, what we need is containerization, right? We spoke about containerization in detail in the past. What it will do is basically package everything along with the code that is needed, whether it is configuration, dependency or anything for that matter, and bundle it together in a logical unit called container. So answer to all of these problems that we just now discussed is building a container and then using that to deploy to different environments. So in short, a container is essentially a fully packaged and portable computing environment, which will contain everything that our code needs, from binaries to libraries to configuration files to dependencies. And why are we talking about containers is because when we want to talk about Docker, Docker is a tool that is helping us to create and run those containers. So that's the basic building block. It is important to understand what is the challenge and what is a container. Now let's move on and look at what is Docker. Docker is one of the most prominent tools which can automate this deployment of applications in the form of lightweight containers to different environments. Because building these containers, running them, maintaining them also requires effort. For that, Docker is the solution. It helps us to automate this entire deployment of applications in the form of containers. Three things that Docker helps us to do. One is build, second is ship, and third is run. These are the three important things. Docker helps us to build these containers, ship these containers to different environments, and then run the containers efficiently. These are the primary functions that Docker performs for us to ease out our deployment process. Now Docker can run in two modes, like client-side application program. So Docker can run as a client-side application program which will help us to create containers, and it can also run as a service on the server to run the containers. One of the very good features of Docker is it is shareable. So developers can share containers among themselves. among different environments, which helps them to take care of all those peripheral tasks of dependencies, configuration, etc., etc., managing them along with the code. So that's how Docker is helping us. Now, there are certain things that we need to know when we talk about Docker, and those are the ones I'm referring to as Docker components. So, things like Docker image. What is a Docker image? So, image is nothing but it's like something that you will use to create a container. So, when we are working with cloud, you must have heard about machine images. So, basically, what we can do, we can take one machine, install, deploy whatever we want, and then take a snapshot or image of that machine which can be reused. So Docker also works on that kind of a principle where we can create Docker images. Those images will be stored in the Docker hub or registry, just like we store code in the repository. Docker can store images in the registry. What is Docker container? Docker container is the basic building block. As I mentioned, container is the basic building block, which is a bundle of all the dependencies along with the code. That container is getting created from the image. So whatever image we build, a Docker image, we instantiate that image to create containers, and those containers are used to run our code in different environments. And Docker can run in both client and server mode for creating the image and for running the image. As I said, on the client side to create the image, and as a service on the server to run the image. So whenever we talk about Docker, these are the terms we will keep hearing: the image, the container, the Docker registry, and the Docker client and server. So if I have to put all of these together, the way it would look like is we would have a Docker file. So we have to write a Docker file to create an image. That Docker file forms an image. The image is used to create containers, which are our basic building blocks for any containerization process. These images are getting stored in a Docker hub or a registry, and from that registry different developers can pick up the image and then instantiate Docker containers. One more thing that I'd want to touch upon is what is the difference between a Docker container and virtual machine, because a lot of times there is a confusion saying that how are containers different from virtual machines. They are also doing similar kind of thing for us. So it is important to understand that distinction. So now let us look at how it actually functions. So for any physical machine, there would be one layer which is the hardware, which is our CPU, our RAM and all of that. That's the hardware. On top of hardware, this is the OS which is sitting on top of hardware. But when we talk about OS or operating system, it is basically divided into two major parts: the kernel and the applications. Kernel is responsible for talking to the hardware, and applications is the layer of OS which talks to the kernel to perform certain functions. So let me give an example. We know that Linux as a distribution has many flavors. It has Ubuntu, it has Fedora, it has many different flavors. If we talk about a Linux distribution, the kernel part would be the same, but the applications part would differ with each of the flavors that Linux has. For example, with each flavor you would have a different GUI, a different set of features. That is a part of application. Why I wanted to explain these two layers is because it will help us to understand how the containers and VMs are different. So when we talk about containers, so these two layers are there, right? When we talk about containers, they are actually operating at the applications layer of the OS, which means they are still going to use the kernel of the host machine. So whenever we talk about containers, they are actually operating at the applications level of OS, which means they will not have their own version of OS bundled. They will still use the host OS's kernel. But when we talk about VMs, they are actually operating at the level where they are having their own OS. So they are abstracting out the kernel and applications part also. So that way VMs will have, when we create a VM, it will have a OS version bundled with the VM. That is the reason we can actually have a Linux VM working on top of a Windows machine or vice versa. But the flip side is that the VMs are much more heavier since they are having their own OS version, they are much more heavier as compared to the containers. So containers have the advantage of being lightweight and hence having the advantage of being much faster than the VMs. So that is a very important distinction to make for containers versus virtual machines. Now this was all I wanted to talk about Docker. I hope this video helps to clarify some of the concepts about Docker. Please like, share and subscribe to the channel and keep watching for more interesting videos. Thanks everyone.